Welcome to the Android course from wantch. Let's just take a moment to introduce the course. This is a document with the title wantch Android Course Introduction, and you can always find these documents in the documentation folder, and the folder containing the document will have a name that's very similar to the actual title of the document. So in this case you will find this document in the folder Android Course Introduction. So let's just take a moment to go through the conceptual approach of the course. This course is not like a software engineering or computer science course. We're not trying to lay foundations or general principles or go for anything too theoretical at all. Rather, it's a practical introduction to creating Android applications for a developer, and in particular a Java developer who has some experience writing code. You might have, for instance, completed the wantch Android Java Basics course. However, Android is a creation of computer scientists and software engineers. Google produces some of the most innovative and successful technologies used in the coding space or software development space. Some of the names of Google technologies you might have heard of, such as Node.js, GWT, AngularJS, or the Chrome browser, which runs on Google's V8 Chrome runtime engine. These are just some of Google's creations. Now, Google's Android will be an emerging space for developers well into the future. Just think robotics. It was no accident that Google chose to call their mobile operating system Android, where we all know what an Android is. It's Google's clear intention that Android will develop to be the basis or the operating system for mobile devices well into the future, and those mobile devices will become intelligent and they will leave the mobile phone. We've already seen this with the emergence of Google Glass and Google Wear. So where possible, inside the constraints of the course, we have tried to highlight the essential software engineering and computer science principles employed in the design and the application and needed to understand how to write effective Android applications for the Android runtime system. We have tried to showcase a range of Android applications and have concentrated on highlighting the core Android principles and associated frameworks, for example, Android fragments. Now, a fragment is a reusable view framework in the Android support library, and we introduced fragments in Chapter 9, then extend in Chapter 10. Finally, in Chapter 13, we highlight the important third-party framework Action Bar Sherlock, which is an extension of the fragment part of the Android support library. We endeavour to offer you an exposition of core Android concepts and techniques as we work through building a range of modern Android applications. So let's just step through and outline each application that we will build over the length of the course. In the first 8 chapters, we build the 4 applications highlighted below: a test framework application, a newsreader application, a trivia game, and a Google Direction Google Maps API application. In the first 8 chapters, we concentrate on the basic fundamentals and structure of Android projects. For example, in Chapter 1 and 2, we look at how you build Android applications using the Gradle build tool. In Chapter 3 and 4, we look at how you build Android applications using the Maven build tool. Now, for Chapter 1 and 2, we give you the opportunity to learn how to create an Android application with the ability to write JUnit tests using the popular JUnit testing library. Previously, in Android, to write tests, you needed a separate testing project. But now we have an offshoot library called RoboElectric that is based on the RoboJuice framework, which uses the Google Juice injection framework inside Android. Makers of the RoboJuice library have started to develop a library they call RoboElectric. RoboElectric allows you to create JUnit tests inside your application just as you would in a normal Java application. This is a big step forward for Android. We're only at the beginning of this, and this RoboElectric library is very new, but because of the importance of being able to establish a rigorous test framework in any application, we introduced the RoboElectric framework with JUnit testing. In Chapters 3 and 4, along with the introduction to the Maven build tool for Android applications, we introduce the Spring framework. The Spring framework is a popular and widely adopted application framework across the wider Java space. The Spring framework contains a number of important tools, so rather than write everything from scratch, we can reuse the well-designed tools within the Spring framework. And these tools include code injection, an alternative to Google Juice, and templates for data access, and more importantly, from the point of view of a newsreader application, for REST calls. So in this application, the newsreader application, we introduce Android views and also the tools for making REST calls, whether they be application tools available within the Spring framework or the native REST tools available within Android itself, such as Android's HTTP library, Android's JSON tools, and Android's XML tools. In chapters 5 and 6, we start to extend our application design skills, where we can look at more advanced layout strategies, that is, navigation between views, and we can also look at how our application can call the services within the Android kernel. We look at this concept of Android native libraries, and in particular, the actual persistence layer built into Android, known as the SQLite database. We look at how you can create a persistence layer, how you can create object relational mapping just inside your Java code in the simplest way, and how you can construct SQL queries and a persistence strategy inside an Android application. In chapters 7 and 8, we introduce the idea of an application programmer's interface, or as is commonly used, API. We use the Android Google Directions API in chapters 7 and 8 to build an application based on the Google Directions API. The Google Directions API for Android incorporates the Google Maps API for Android. We learn how to configure an Android application to use the Google Play services as a library project for the application. And inside the Google Play services, we set up the support for the Google Directions API and the Google Maps API. We learn how to register our application with the Google Directions API web interface. And once we've registered our application, we learn how to make authenticated REST calls to the external API. To do this, we need to extend our skills in the Android REST tools. In the final 6 chapters, we step through 6 basic Android applications. Each application has a unique feature that makes it stand out. We don't go into the low-level native code in these applications to the same degree as in the first 8 chapters, but we actually point out the key Android components used in each application and how it relates to the unique feature of each application. So, for example, in Chapter 9, we create the Android Selfie application, which is a basic clone of the very popular Snapchat application. And in this application, the key feature is the pass.com API, which is rapidly becoming a standard API for application. So we look at how to register the app with pass.com, how to register the keys to make authenticated calls into pass.com, and how to start to use the pass.com services, such as its online users authentication and database service. And we also introduce a new core view technology for fragments. So we looked at fragments previously, but we start to explore and discuss and unpack the fragment technology in Android and the support library implementation of that technology in Chapter 9. In Chapter 10, we create a fitness app for Android, and the key feature of this app is that we focus very strongly on Eclipse and using the Eclipse IDE. So if you want to become an Eclipse developer, then Chapter 10 has a lot of good resources for creating applications inside Eclipse. We use Eclipse as a build tool rather than Gradle or Maven. In Chapter 11, we look at creating graphical applications in Android. Now, graphical applications are a big area across the Java space and wider programming languages in general. we must employ strategies to deal with the demands of graphical programming. In Java, we've had traditionally two approaches. There is a canvas-based approach, as found in Java Swing, or the Abstract Window Toolkit approach, known as AWT. Android uses canvases and drawable types, and the basic idea is you have basic drawable types that allow you to obtain collections of bitmaps that you can display in canvases. So if you are used to the Java Swing approach, then you will be right at home in Android. In Chapter 12, we look at the YouTube API, and in particular, we look at strategies for dealing with high memory demands and high or big file systems. So we look at strategies for caching in memory and file systems. In Chapter 13, we look at the important and popular Action Bar Sherlock framework. In Chapters 1 to 8, Chapter 9, and Chapter 10, we look at fragments, and we slowly develop more sophisticated strategies for working with fragments. And fragments are a part of the Android support library version 4. The Action Bar Sherlock framework is an extension of the Android support version 4 library. Action Bar Sherlock has much of the boilerplate code in fragments encapsulated into superclasses. These superclasses are the Sherlock base activities, Sherlock activity, and Sherlock list activity. So we look at the three fundamental Action Bar Sherlock types: Sherlock activity, Sherlock list activity, and Sherlock fragment. And we see how we can create sophisticated fragment views and navigation schemes with a minimum of boilerplate code by using the Action Bar Sherlock framework. Finally, in Chapter 14, we put everything we've learned in the course together. We create a company profile application that you can use as a template application if you so choose when you continue on working possibly as an Android programmer in the commercial sense, or you want to break into the programming space as an Android programmer. Then you need a portfolio. You need some applications that you create in the first instance that showcase your skills as a programmer, and you can use this portfolio to get contracts and get your first step into working as a professional developer. So the company profile application can easily be extended with many views based on the skills we've developed in the previous chapters. Now that we've outlined all the chapters, what they do and why we have them, let's get started with Chapter 1.